Welcome to the Faculty Forum Online, a program of the MIT Alumni Association. I'm Judy Cole, EVP and CEO of the Alumni Association, and I will serve as moderator. MIT alumni who wish to ask a question, please enter your first name, location, and question in the form on your screen. We will try to answer as many questions as possible, but I'm sure we won't be able to get to all of them. Our guest today is Munther Dahleh, the William A. Coolidge Professor of Electrical Engineering and Computer Science. He is also the Director of the Engineering Systems Division at MIT and the Director Designate of a new unnamed entity at MIT that will tackle global problems with an interdisciplinary approach. Professor Dahleh, could you start by giving us a brief overview of this new entity and what are your hopes for it?
Thank you, Judy. Yes, actually, it's my pleasure first to be here, and thank you all for your attention. I have a few slides that I would like to run through very quickly. The new entity, in a nutshell, is concerned with providing analytical tools to address societal problems. And I'm trying to see how that works. Yeah, okay. So what are the societal problems that we're talking about? Well, in general, we have many challenges for the society. Some come from energy, transportation, social interaction and social networks, finance, risk and efficiency, interested in sustainability of systems, and certainly interested in even physical systems like communication systems. So these are a large number of societal problems, and MIT is very strong in many of these areas, and we have a lot of faculty who are thinking about them. So what is the angle that the entity is taking? Let me give you an example. Today, if you try to understand the effect of a storm on the power grid, you'll find that that problem is quite challenging. The power grid is probably one of the most complex engineering systems that we have built. It has generation, transmission, distribution. It has coordination among system operators. And today, we're even bringing in renewable energy, renewable resources that are adding to the uncertainty of the power grid. But more importantly, you have to understand that the power grid is primarily like a supply chain system. It's trying to take electricity from the generation and deliver it to the consumer in real time. It has to do that in real time. So the consumer side is critical. All of us act in a strategic way in order to maximize our comfort and use the electricity for our own benefit. And sometimes we want to do that at the time when electricity is scarce because of either a storm or a heat wave and what have you. So that's one aspect of this problem. Another component of this problem is that there are actual electricity markets in the loop at multiple hours. And if you want to understand how the grid will behave within 20 minutes, you'd actually have to understand how those markets are in the loop. So you have engineering systems, you have the people, and you have the markets, and of course we have all the regulations, the environmental issues, and what the system operators are trying to do in terms of meeting demand through supply. So very complex problem, a lot of different pieces. And if you look at my diagram over here, you actually see exactly this summarized in a nutshell. What it is the interaction between engineering system, social behavior, and institution. Three heterogeneous components together interacting contribute to the well-being of the grid, to the issue of cascaded failures, to the issue of outages. So why now? Why today are we interested in this? Well, I think the biggest change that has happened in the last decade, I would say, is the availability of data. The fact that we can sense detailed information from the power grid, we can actually today find out how consumers are consuming energy in their own homes, and certainly we can track markets and we can understand how regulators work. The data is available, the data itself is heterogeneous. Some of it comes from physical laws that we understand, like the laws of electricity. Some come from behavioral aspects that we understand a lot less. And some come from institutions that have governance issues and states and government and what have you. So how do we take the data and our understanding of these systems and begin to decide how to regulate and how to actuate and how to mitigate risk of cascades and outages. And that sort of, in a nutshell, describes what the entity is trying to do, combining these heterogeneous components in such a way, in a rigorous way, that allow us to address these kind of complex problems. So that's the value proposition of the entity. On one hand is to create both research and educational programs that will allow addressing for these complex problems in terms of, as I said, monitoring, forecasting, actuating, changing the dynamics of these systems so that we can get better behavior. So we are looking to train the next generation students that will be able to tackle these types of problems. And side by side with this particular objective is to also launch a 21st statistics effort at MIT, 21st century statistics effort at MIT that is able to look at these sort of large data sets, heterogeneous data sets, and sort of make sense out of them in terms of building models and being able to make decisions on these models. You can see that the intellectual pillars of this entity lie in what I would consider three components: information and decision sciences that describe how do we optimize, how game theory is defined, how do we do stochastic modeling, how do we go from data to models to decisions. This is an area that MIT is fairly strong at. We have a lot of people who do this work, and it's very good. Another dimension is the 21st century statistics. As I said, this is not the 19th century statistics, but looking forward as to what's needed in terms of the analysis and the utilization of large-scale data sets. This is an area we're building as part of the value proposition of this particular entity. And the third component, and the most important component for this, is the integration of human or social and institutional behavior. How do we bring the social sciences in terms of understanding behavior? How do we create incentives for people to do the right thing? How do we roll that out so that it makes sense to all the decision makers? And how is that integrated in the engineering problem so that the whole thing works really well? And of course, we cannot do this without having domain knowledge. We believe the domain knowledge is available at MIT. This is not the ownership of this particular entity. The entity will work very closely with a lot of units within MIT to enable the interaction of these pillars with the domain experts. And that's my entity. And of course, my hopes is that this, very quickly is to be successful at attracting first faculty who are at the interface of these intellectual pillars, people who are able to think about social phenomenon and economics of complex engineering problems, but also have the depth and the analytical tools that are able to use the data to provide a better understanding, a rigorous understanding of these problems. So attracting the faculty, defining the academic programs that match this vision, and finally attracting the top students to come to MIT. So that's really where I would like us to be in a year or two.
Thank you, Munther. That's a wonderful explanation. I have 1,000 questions of my own that I would love to pursue, but I would feel I was not being fair to our alumni guests who are online. So questions are starting to come in from the live audience, but we also did collect some questions from alumni ahead of time. So I will start with a couple of those. Brendan in Cambridge asks, what is the role of the non-expert crowd in addressing these challenges, and how do you envision deploying the crowd to maximum effect?
I mean, that's an interesting question. I think that maybe actually first let me say what is the role of the expert crowd and then go to the unexpert crowd. So I think MIT in the past have taken leadership in creating areas and creating fields. And what we're trying to do in this particular entity is to create the leadership for looking at the intersection or the interaction between engineering problems and social sciences. Mm-hmm. We are promoting that as a research area. We're creating PhD programs in that domain, and we are going to have our students and faculty formulate and solve some of these problems that face society. And we will invite the experts of the world to engage with us in this journey. I think that that's a very important dimension that MIT is taking the leadership with. So we will be the hub for creating this activity, and we hope that the rest of the world come into it. The unexpert interaction is tricky, but actually is quite interesting, because my own assessment of how we're going to make progress is by the utilization of the live experiment. You know, it's really difficult to make progress in these areas and create controlled experiments. What you have to do is you have to measure from the real data. Today, all of us use well, not all of us, but many of us use the Google GPS system on your phone. In a sense, what you're doing, you're engaging the live experiment. And at some point in time, potentially recommendations can be coming to you through that and telling you, well, avoid this route and go through this other way. And how you engage that and how you respond to that, and that data that gets collected becomes a central part of how we propose models and analysis of these models, and how we can actually actuate at the end and decide how to reduce congestion in the street. So engaging the live experiment is really important. Of course, crowdsourcing is a great way of doing this, and a lot of people engaging in the analysis of some of this data and providing that back to a centralized unit. One of the things we are trying to do at MIT is to create a data hub where data that is not tagged and sort of private comes in, but has a ton of information about our lives as we live them, and we want to be able to process that and give back to the community. So the crowdsourcing aspect of this will be also important.
Excellent. And a follow-up question is, how will you prepare students, and I would add your colleagues, for this institutional transition? This sounds like a big task just in terms of moving it forward.
Yeah, so preparing my colleagues is the challenge. I think the students will just admit them with that orientation. So we have, when we developed the blueprint for the new entity, we engaged 40 faculty in this process from across 5 schools at MIT. And it was amazing, you know, to have, if you have a committee of 3 faculty, you probably have 3 opinions. So when you have 40 faculty, you have 40 opinions. And what was amazing, within 4 months, we actually converged on the vision of the entity with unanimous interest and agreement. MIT recognizes that this intersection is overdue and that needs to happen, and people from all sides of MIT are looking at this and saying, yes, but we have to do it right. And so I think the challenge is not so much that we should do it, but the challenge is how can we do it so that it's successful and we're engaging at equal footing and so forth. And I think that if you think about the past, engineering managed to engage sciences very well, and computer science and other engineering, working with biological systems people and working with chemistry and physics and so forth. Now what we're doing the same thing with the social sciences and bringing that intersection to MIT. For the students, I think this is exactly what we're doing right now. We are developing the academic programs, and we will begin to attract a body of students who are willing to educate themselves in multiple domains, multiple pillars, as I described, the intellectual pillars. They will acquire the depth needed, both from the analytical tools as well from the human and institutional behavior aspect, which comes from social sciences. So we're mapping out these academic programs at the end of this year, and starting the fall, we will go out to universities and advertise this program and talk about, you know, the upside of it and where, you know, if you finish your degree, where you will end up. We're starting at the graduate level, and then at some point, you know, after we are successful, we will go to the undergraduate level.
So you expect your first students in the fall of
2016? Yeah.
Okay. So going to some of our alumni questions, Ted in Phoenix asks, when do you expect to see a robust network system that will support better individualized K-12 teacher-student learning with real-time assessment? And how will this entity influence the education systems?
I cannot give an expectation of when we will see that. The MITx with the edX platform certainly is providing the beginning of an online network that allows you for self-assessment. It's more of an advanced tool right now for students above 18, although my understanding is many of the high school students are now taking courses on the edX platform. This is the beginning of a revolution that MIT started several years ago, and I think it is going to trickle down to the high school level. Where we are helpful is in actually the dynamic aspect of it. So right now you have an assessment, so you can take an online course which will be modularized, and at the end of the module you can be asked some questions to see how well you understood that module. And I think what we can bring into the table is a reassembly of a set of lectures for you based on the responses that you have made, so that the education is targeted to your strengths and weaknesses. It requires a very nice organization of the material, modularization of the material, and very strong access and learning. As you're engaging the platform, it learns what you know, what you don't know, and then sort of assembles the right lectures for you. And that's on the horizon. People are thinking about that, and that would be great for K-12.
So let me make sure I understand it. You're talking about an individualized, dynamic delivery system that is based on some set of questions that you answered that revealed strength and weakness.
That's correct.
Great, that would be fabulous. So Frank in Boston wants to know, how do you foresee the Faculty of Engineering, Sloan, or Science collaborating in the years ahead? Will this, how will this change their collaboration?
I think that this is exactly what we're trying to do. So part of the structural aspect of this entity is that we decided it would not be a department, which means that it would not belong to one school, but rather it will be part of the 5 schools. Faculty in the entity will be from the 5 schools, and the governance will report to all 5 deans. That's a structural issue, and the implication of that is the engagement of all the faculty from different schools. Already, if you look at the composition of the core faculty that we have today, they come from at least 4 out of the 5 schools. And if you look at the statistics committee that's sitting around designing the curriculum, or actually searching for faculty, it comes from departments from all the 5 schools, and engaging amazing conversations and discussions. And part of where we have to get to is understanding each other and understanding our cultures and our values, because we have different values in different schools. The entity is structured to encourage that interaction. I see that happening slowly. As I said, engineers and scientists have done a pretty good job at doing this, and we have institutes within MIT, like the Institute for Medical Engineering and Sciences, that is collaborative engineering and science. And we also have a track record of engineers collaborating with economists. But now what we're trying to do is expand that for engineers and economists collaborating with social scientists, and of course business faculty. So if you want to understand the question of financial risk and cascades, you need someone who is an expert in financial engineering, but you have to understand more about the psychology of the creditors, the investors, us, as we see signals and we get scared and we run with our investments, even though we don't really understand the details of why the stock market is beginning to drop. So an understanding of the psychology, understanding of finance, the engineering aspect of all of this, and I see that growing, and we already have the faculty engaging that kind of a discussion. So I see that as a up and coming.
Yeah, it sounds an awful lot like a formalization and extension of what is already happening somewhat organically at MIT and has for many years.
That's correct. That's correct.
So Bill in Hagerstown, Maryland asks, do you anticipate any technology in the future that can provide electrical power generation on site, like space heating is generated on site?
That's possible, and it's out of my domain of expertise, but anything is possible in terms of innovation. I would say that in terms of the power innovation, power electronics, and so forth, I think we've already seen a revolution in that area. And where we are lacking today is at the systems level, the integration of all of these components to provide the service that we're asking for. But I think a lot of innovations, a lot of clever ideas, and so anything is possible.
Yeah, and it's how do we knit them all together so
That's
that we get a better
problem.
system.
Yeah, yeah, yeah.
Yeah. Sunish in Brookline asks, what is the future at MIT for engineering technologies for seniors or the disabled? Will this effort direct research in those directions?
That's an interesting question. I think this is an area of growth for engineering and MIT as a whole. I was partially involved with a project that supported technology for the blind and trying to use wearable computers or wearable devices and iPhones as a way to allow a blind person to engage the community around them as if they can see who they are. You know, we have a pretty strong vision systems. We have very fast computing sitting in your iPhone. And it had elements of what I talked about because it is, after all, a societal problem, and it has a very important psychological and sociological aspect of it that needs to be understood. I mean, just the whole idea of translating the technology that you put on an autonomous car to a technology that you put for a blind makes a huge difference in terms of the realization of that technology. So you can't just simply borrow that technology and put it elsewhere. The fact that a person is going to be using it, and that person comes from a certain background and thinks about the world in a certain way. I think this is up and coming. We're very open to a lot of, in fact, we're very encouraging to a lot of these collaborations within the new entity. I would say that right now I'm spending most of my time at the nuts and bolts of creating this unit, the sort of the foundation that everything will be built on. But I can see a lot of the stuff happening organically within the entity.
Yeah, it seems to me that some of these engineering technologies for seniors and disabled is also happening in the media lab. Is that's going to be a part of the new entity?
Of course, yeah, absolutely. I mean, you know, as I said, you know, we're across 5 schools. Yeah. We're interacting with many faculty. We have some core faculty in the entity from the media lab. So clearly, you know, that's also another touch point for us.
Miko in South Florida asks, are you engaged with the appropriate regulatory bodies in federal and state governments in order to affect legislative change through this research?
That's a great question, and the answer is we are trying to do that. MIT is very well connected, and individual faculty have connections with different regulators. We're trying to make this a lot more systematic, institutionalize it. I'm happy to say that we do have an executive director that came on board right now. Her job is entirely try to understand the partnership system. Who are our partners? How do we bring them to the entity? How do we get the maximum value from them and provide maximum value back? So we're designing the strategy right now of how to do it, but absolutely an important piece of the whole puzzle.
Laura in Ayer, Massachusetts asks, how much of the formation of the new projects like this is student or market driven, and how much do you think about the current or prospective students' input in your approach to this effort?
So
I was actually wondering the same thing. How are you going to choose which projects you work on?
Yeah. So okay. So first of all, the vision is market driven because we see that vision in all of the societal problems. We see that interaction. We see the need for engaging engineers with the social aspect and the economic aspect. Students that are applying to MIT right now are talking about these things in their essays. They're saying, I want to come and change the world. I want to bring technology to the poor. You know, I want to create more sustainability. And so, you know, the students are talking about it. So clearly we're impacted by the word opinion. We are seeing the problems. And the third component is that many of our faculty, as you said before, are already organically dealing with these issues, and we're trying to institutionalize that. We don't pick the problems in the entity. And MIT never picks problems for faculty. Faculty pick problems, right? And so that's the way things work. You know, faculty get interested in an area and they assemble a group around it and they start taking students to work with them and they take off. What we can do is bring the industry, the corporation, the regulators closer to the faculty so that the collaboration is easier, but the faculty will choose.
Well, and it sounds like it's sort of the forum within which the faculty will find each other and the students that are interested in their problems as well.
Right, and in fact, we will be admitting the students who are interested in those problems.
Sort of a convener of people interested in these same kinds of problems, and then they can find each other more easily to work on them.
The students are the nervous system of this place, right? And so, you know, they're really the ones that move around and make things happen. And so, by us creating the right academic programs that are attractive to the brilliant students out there who want to come to MIT, these are difficult problems, and you know, so we often write in our report, and the superhumans who are going to come and join us will do the following, right? We have very high expectations of the people who are going to come and work on these problems, but MIT has very high expectations of our students. So the bottom line is we need to admit the students who are thinking that way, who are out there to change the world, but are willing to do the work to do it. And that's how the place can change.
So Matt in Los Angeles says, first, congratulations on undertaking this approach.
Thanks.
Will the Poverty Action Lab be involved? In the end, technology or accurate modeling of systems can't be properly employed without understanding social behavior.
The answer is probably yes. I mean, the conversations are happening. Absolutely correct. You cannot make change without understanding social behavior. You know, the example I often use is we recycle, but we don't get paid for it, but we all feel very good about doing it. And why? Because we want to do the right thing for the environment, right? And so you created an incentive, which was not financial, and we're all following it religiously. So how did we do that, right? So today, if we wanted to conserve on using power or energy, and you know, a lot of conversations about real-time demand response and price-driven response, well, it could be incentivized completely differently, and not by price, but by some other way, some other mechanism, social pressure, right? And that's a social phenomenon that we need to understand.
By raising people's awareness of the effects of
you
their
could be a lot
behavior.
more effective than just saying you save you know, $20 in your bill.
Yeah, it seems to me that very often things get boiled down to an economic incentive, where sometimes the altruistic incentive can be equally or even more so effective in terms of changing behavior.
Right, and there are people who understand this very well, and I think that, to be honest, I think when we come from the engineering side, from the economic side, we always think in terms of cost and objectives we can optimize. Mm-hmm. Social scientists think about the phenomenon itself and how people respond to it, and so we would have to learn a lot more about people and their behavior than just simply making assumptions about it. So I do agree with the comment.
So Charles in Albuquerque says, your effort seems focused on understanding and managing complex systems. Are complex systems truly manageable? Is there a useful general theory of complexity?
Probably not to the last question. And you understand complex systems by simplifying them. And we've done that in engineering over and over. You don't tackle a complex system by making it complicated, right? So the question, how do you simplify? And that's it's a notion of abstraction that engineers and computer scientists have done over the years. I don't remember when I took my first control theory class, my professor walked in and he said, you know, the 747 to me is a second order differential equation. It's like, you know, what are you talking about? You know, 747 is a very complex system. I mean, so he said, well, it's really a second order differential equation. It's not more than that. And it took me many years to understand what he was saying. You know, the point is, with a second order differential equations, if some of the people have taken differential equations know what I mean by that, it's a pretty simple and trivial problem to kind of tackle, and that's the baseline design for the 747, right? And that's how you start thinking about it. And you don't start thinking about it as a complex, interconnected pieces that you're trying to do everything at once. That's not how it works. So the abstraction is important. How do you come up with a model that is really simple but captures what you're trying to do, right? That's the interaction with the domain, and that's the cleverness and the creativity of the engineers that allow you to do what you're doing. And what we're trying to say is we will never abandon that approach that engineers have, but we want to include in their thinking the social and the institutions. That's all. But we still want the engineers to think like engineers.
Ralph in Virginia says, as a TPP and a TMP alum, I'm concerned that the art of creating effective policy may be lost by the heavy empirical focus of the new entity. How will future TPP graduates who have an interest in pursuing non-empirical research be able to thrive within the new entity?
It's a very good question. What does it mean not to be empirical? Are you not data-driven? What are you driven by? Are you making assumptions and so forth? I think there's room for systematic, rigorous analysis that is not necessarily empirical. The question is actually still on the table. We are engaging the major policy researchers on campus to try to understand exactly that question. To what extent the empirical, rigorous sort of approach of the entity works well with somewhat of a qualitative piece that could be added to the policy making. I believe that it does work very well, but we have to understand exactly what we're saying. What does it mean to be non-empirical in our work? But we haven't concluded on that. We're still thinking about this problem. Well, it's a good question.
At least you're talking about it.
We are talking about it, yeah.
Stephanie in Cleveland asks, businesses and governments are very likely to be interested in this. Do you envision a role for industry and or government in driving, guiding, or supporting the new entity and its programs?
Absolutely. This is what I mentioned earlier about the partnership program. We would like to identify the flagship industrial partners and government agencies and regulators who can be part of this. And we're trying to figure out exactly how we can engage them and how we can get the value from them and how can we help them. So that's a big piece.
Has that been coming through the Industrial Liaison Program?
Well, we are collaborating, but as I mentioned, we have hired the executive director who is going to do this, and we have faculty who want to engage that process. I think it's one of the critical cornerstones of building this new entity. So it's a very important question.
I love this next question from Sonal in New Hampshire. Were you thinking about radical solutions to this winter's challenges in the Northeast? How was this a good example of the kinds of problems a new entity like this could address?
I don't know if this is a good example of what we want to address. I don't know if anybody can address this problem. Maybe the best thing we can come up with is effective ways of getting rid of the snow. Can't stop the snow, but we want to get rid of it. Yeah, you know, it's interesting. In Cambridge, we had groups engaging the whole discussion about where would you take the snow, you know, and why don't you dump it in the river, you know, or in the ocean? Why is it? Why are we piling it up in parking lots, you know? And then there was a question of environmental pollution that came up, and it was a pretty interesting debate about whether the pollution is coming first by putting the snow in the water, or waiting until the water until it melts, and then the water drags everything to the ocean. So here's a question of policy and regulation that probably could have been handled better than a sort of a blog debate in a more empirical way, and so we could have been helpful that way. But in general, this has been an interesting winter, to say the least.
And then as a follow-up, what about transportation systems?
Transportation system is a big deal. It's a big flagship problem for this new entity. First of all, MIT is very strong in transportation, in the domain itself. And we have, it's very empirical, it's very rigorous work. And transportation people are thinking exactly in the direction that this new entity is thinking. And we have many conversations with that group as a whole and with individuals. So I believe transportation is an important flagship. As I said, we definitely are very interested in that problem. We think also it's one of the, you know, whether it's a multimodal issue. It's not a transportation just worrying about road transportation or air transportation. We think that one impacts the other. The kind of example I like to give is when we had, I think it's a couple of years ago, we had about 7 inches or 6 inches of snow in Atlanta that resulted in several hours delays in LAX. And a lot of people were sort of wondering, you know, how could that happen? Of course, you know, delays in airports cascade, and we know that, and that's a problem that we obviously would like to think about as well, and people are thinking about those problems. But why would 6 inches of snow cause this cascade? I mean, surely we could have plowed the airport in Atlanta. I mean, we're not asking for a lot. And here's a situation where it wasn't really the airport that was the problem, but rather transporting people to the airport that was a problem in Atlanta. So you couldn't get the people to the airport to run the airport. The airport itself, it can be easily plowed. And that's a multimodal cascaded failure model that happens a lot in transportation systems. So we think that that's plus how people can be incentivized to do the right thing. What is the motivation? What is the incentive structure? How do you lay out these mechanisms so that you can reconfigure them as you have cascades and delays and what have you, is a great problem for the entity.
Mm-hmm. So Lars in Cambridge asks, you've been at MIT for many years.
Yeah.
How has the Institute's researchers' approach to solving the world's energy problems changed over time? And how about its approach to renewable energy or power grids?
So we definitely made a substantial jump with the MIT Energy Initiative. There's no question about that. And I remember at the inception of the initiative, Moniz was the director to be, and there were calls asking people, do you work in energy? And a lot of us looked at ourselves and said, no, I don't work in energy. I work on some other things, right? And then very quickly, in terms of meetings and discussions about what the pressing problems in energy are and what are the pressing problems in the power grid, and then the next response is, yeah, guess what? I'm probably working on the power grid. I just didn't know it, and so what it did, it brought MIT to focus on that problem, and that was an amazing step, I think, in the way MIT has dealt with energy issue. We still are trying to build more muscle mass behind the power grid itself. I think we've been looking into renewables, we've been looking into nuclear issues, but the power grid is something that we want to build. As I said, maybe more faculty presence. And I know several departments are interviewing faculty in this area because we want to bring in more people in that. So MIT has definitely changed, and I think it's a serious look at those questions.
Jake in Boston asks, what are your initial focus and goals for the first year of the new center? Is it a center? It's an entity.
It's an entity.
Yeah. It's not a center. Given the broad scope of the mandate, are there any low-hanging fruits the new entity can pick first?
We picked one low-hanging fruit, which is we are planning to launch a minor in statistics, an undergraduate minor in statistics. It's been designed, and the course has been listed, and proposals have been made to the Committee on Curriculum, and so that's one low-hanging fruit, and we've done that. Everything else is not low-hanging, but it's there, and we have some objectives. First objectives, I think we want to build the effort in statistics, so we are searching for faculty very, very rigorously and extensively, and we're making offers as we speak. As I said, the other piece was designing the academic program for the PhD program for the entity, and we have the draft of that proposal out. So those are the things that we're focusing on right now. And of course, getting the support of the institutional support within MIT has been something I've been spending quite a bit of time on. I think we view this as essential for collaboration. We don't think of us as competing with any entity at MIT. And how do you structure the org chart is really important for doing things of the sort, and we've been doing that. So a lot of it, as I said, is laying out the nuts and bolts of the foundation so that everything that builds on it is collaborative and systematically sort of productive.
So Mona in Chicago is asking about whether or not academic research can influence or improve the banking system to avoid future recessions. That sounds like it intersects with policy too.
Yeah, I think that's an interesting question, and we have collaborators from Sloan School in the Financial Engineering Center heavily involved with the new entity, and certainly looking at the questions of central banks, systemic risk, cascaded failures, questions of recessions and so forth, right? And it's not a trivial matter to prevent recession. I think sometimes maybe the way you want to think about it is reducing the peaks and valleys as opposed to preventing the oscillations. Markets will oscillate, and financial systems may go up and down regardless of what you do. But at the same time, I think there's a very strong effort at MIT to think about how do you engineer those financial systems and recognizing their independence and how they make decisions. What is it that, say, the government, the federal government, can do to regulate some of the extreme behavior of the market? So this is another flagship of the entity, by the way. We have strong presence in this area.
So Bruce in Cambridge, this sounds like it must have come from an insider. You have a nickname, the Connector. Do you like it, or is it a little daunting?
I don't know. It's a name. I just live with it.
So one last question. This year will be your last year as the housemaster at McGregor. Can you talk about what that role has meant to you?
Well, it's yeah. I mean, I think this is a hard thing for us because McGregor was our home for 20 years. It's been an amazing experience. It's a way of life. You know, you engage a community of students, roughly under 21, and you do a lot of activities with them, and you see them every day, and they see you every day. Well, some of them see you every day. Your kids grow up among this young population, and I learned a lot. I mean, I certainly don't think I would have had the same experience being just a professor at MIT without engaging this community. It's a very vibrant body of students. MIT, as I said, the students are the nervous system of MIT, and when you live in the houses, you recognize, you know, the vibrancy of the students. You also recognize the challenges they face, and some of the easy things and some of the difficult things, and it's a privilege to be part of it and to be helpful, at least in the best way you can, for people to succeed. But you learn a lot about the young crowds and their value system and their thinking and what makes them tick and so forth. And it's been, I mean, I would say it's been wonderful, but everything has to end, and I think we decided that it's time for us to kind of start a new chapter in our lives. So,
have they found your successor for that role
not
yet?
No.
No. You're going to leave big shoes to fill, I'm sure.
Thank you.
On behalf of the MIT Alumni Association, thank you, Munther, for your insights, and thanks to our viewing audience for joining us. We encourage you to continue discussing these topics on our blog, Slice of MIT, by following the link that will appear on your screen, and on Twitter using the hashtag MITFaculty. You can also view an archive of past faculty forums online by visiting the Learn section on the Alumni Association website. Please join us next month for another session of Faculty Forum Online.